Greetings. So today we'll be looking at the device called as a driver's anti-sleep device, and let's dive right into the presentation. Let's start with an introduction. So in today's world, it is really hectic to keep up with all the modern day solutions and problems, and we can all get tired sometimes. So let us consider a situation when a person is driving back home from work late at night, and he is really exhausted from his tough day. His hands are on the wheel and his foot is on the pedal, but he starts to feel sleepy and he starts to fall asleep. This can lead to really unfortunate situations and, in worst case scenarios, even lead to accidents and death. So, in order to avoid that, we've come up with a solution called as the driver's anti sleep device. So, this device will alert the driver whenever he feels drowsy and keep him awake, so avoiding accidents and also saving lives. Now let's look at the key components and the block diagram. So the key components are the battery, diode, regulator, timer IC, relay and the buzzer. And we can also incorporate a tilt sensor if we need to. So the battery gives AC current and the AC current needs to be converted to the DC current, so we have used a diode, and the regulator will step down the current required for the timer IC, relay and the buzzer. So the current is supplied to the timer IC, relay and the buzzer. Now let's move on to the working. So first, the timer, we'll set a timer to the timer IC. Let's consider it to be 30 minutes. We can set it maybe 1 hour, whatever time we require. So for now, let's take half an hour as an example. So every half an hour, we have to reset the timer IC. So the transistor will drive the buzzer and give an intermediate beep if it is not reset. So like every 30 minutes, we'll receive a short intermediate buzz from the buzzer. Once we receive this buzzer, we have to reset the timer IC, let's say 1 minute. So we've given the time limit as 1 minute. So within that 1 minute, the timer IC has to be reset. If the timer IC is not reset at that time, the output gate will close. So we have given a time of 1 minute. So after the 1 minute, the output gate closes and the relay will deactivate the resistance. So once the relay acts as a switch. So once it deactivates the load, the buzzer will start to buzz and it will keep buzzing until the timer IC is reset. So thus awaking the person from sleep. Once this timer IC is reset, the buzzer will stop and again the whole process will continue. So after it has been reset, it will count for again. The clock will start counting till 30 minutes again, and then the process keeps going on. So we can also incorporate a tilt buzzer into this. So the tilt sensor will actually sense if the person's falling asleep by tilting the head, and then it will start to sound the buzz. This can be incorporated and it is optional. Or else we'll have to work with the timer IC by setting the timer. And suppose let's say that the timer IC is reset within 30 minutes, maybe 15 minutes. So from that 15 minutes point of time, it will take another 30 minutes to check to sound the buzzer, the intermediate buzz again. And that's how this whole um, timer IC and all the driver sleep anti-sleep device works. So in conclusion, uh, this will alert the driver to prevent them from dozing off in their wheel, and it will also be really useful for people especially traveling at night and those who tend to travel long distance a lot. So by detecting signals of drowsiness, this device prompts the driver to stay alert and avoid potential disasters. These are the reference that I've used for this presentation, the websites I've referred, the synopsis for this whole device, and the YouTube link video about the circuit. Thank you.